All right, so here's a question. A proton goes from point 1 to point 2. Find the final velocity. So this is point 1 right here. Has a velocity of 0 meters a second, so it's going to start from rest. And because it's on the positive end there, it's going to be repulsed downwards this way on the other side here. And then down here, we're trying to find the final velocity. And its potential difference at this point is at 0 volts. So it's going from 120 volts to 0 volts. So let's use this equation right here. So negative difference of potential energy is going to equal potential energy is going to equal difference of kinetic energy. Okay. So let's fill this in for what we know. So the equation for delta PE we're going to use here is charge multiplied by volts. So like Q and then difference of potential difference there. So yeah, let's fill that in. So negative Q and then this difference of volts here. So because it's like V2 minus V1, so V1 is going to be 120 volts there, right? But V2 is 0 volts. So this is going to become negative V2, or sorry, negative V1. Okay, because V2 has 0, so it's just going to become 0. So we can, actually here, I'll write this in fully. So it's like, this is what it's going to look like. It's going to be V2 minus V1. But since V1 is equal to 0, you can just like erase it out. So here, I'll erase it. And it will look like that. And then it's negative multiplied by negative, so we can just take out the negatives there. Okay? So basically what this is going to equal at the top here is just Q multiplied by V1. And that is going to equal, well, we can see at the start here, kinetic energy at the start is equal to 0. So it's going to be like kinetic energy 2 subtract kinetic energy 1. And then kinetic energy 1, there isn't that, right? So it's just going to be like this. So it's just going to be kinetic energy 2. So what we're going to do for that, we'll just do 1/2 mass and then V2 squared. It's like this. And now we're solving for V here, so we're just going to rearrange. So we're going to move the 2 to the other side. We're going to move the 2 to the other side there, and we're going to move the mass to the other side. So we're going to divide by 1/2 and divide by mass. So you're going to get 2Q V1 divided by mass equals V2 squared. And then you can also square root both sides. So you're going to get that. And now what you need to do next here, you're going to fill in all these variables here with the numbers, now, and then you'll get your answer. So this is going to become 2 multiplied by the charge. So we're going to use the elementary charge, sorry, because it is a proton. So that'll be 1.602 times 10 to the power of negative 19. That's coulombs. And then the voltage is 120 volts. That's all going to be divided by the mass. Mass of the proton is 1.67 times 10 to the power of negative 27. That's kilograms. And then, of course, square root that. And that is going to be your final velocity. So I'm going to skip ahead to show what that looks like. Okay, so I put the number into my calculator. This is what I got. So 1.51732 times 10 to the power of 5 meters a second, which is, you can just simplify it to 1.5 times 10 to the 5 times, 1.5 times 10 to the power of 5 meters a second as your final velocity. So that is how you do energy in parallel plates. I'll have a couple more videos coming out soon with some more complicated problems.